This is SpaceTime, Series 26, Episode 86. Coming up on SpaceTime, it now seems human interference has changed Earth's spin axis. A new study shows that Martian sand dunes have been eroded by a shift in prevailing winds following the planet's last ice age. And a water recovery milestone aboard the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown that humans have changed Earth's rotation by pumping out vast amounts of groundwater and moving it elsewhere. The findings, reported in the journal Geophysical Research Letters, has shown that the planet has tilted by nearly 80 centimetres towards the east. Based on climate models, scientists previously estimated that humans had already pumped out some 2,150 gigatons of groundwater, equivalent to more than 6 millimetres of sea level rise, between 1993 and 2010. But validating that estimate has been difficult. One approach lies with the Earth's rotational pole. That's the point around which our entire planet spins. Now, it does move during a process called polar motion, which is when the position of the Earth's rotational axis varies relative to the crust. Now, the distribution of water on the planet affects how mass is distributed, and that impacts where the Earth's axis is. The study's lead author, Kaiwion Seo from Seoul National University, says it's like placing a tiny bit of weight on a spinning top and causing it to rotate slightly differently because of the change in weight distribution. In the same way, the Earth spins a little bit differently on its axis as water is moved around. The Earth's rotational pole actually changes a lot, and the redistribution of groundwater actually has the largest impact on the drift of the rotational pole. Water's ability to change Earth's rotation was discovered in 2016, but until now, the specific contribution of groundwater to these rotational changes was unexplored. In this new study, researchers modelled the observational changes in the drift of the Earth's rotational axis and the movement of water. First, with only ice sheets and glaciers considered, and then by adding in different scenarios of groundwater redistribution. The model only matched the observed polar drift once the researchers included 2,150 gigatons of groundwater redistribution. Without it, the model was off by 78.5 centimetres. That's 4.3 centimetres of drift per year. The location of the groundwater matters for how much it could change polar drift. For example, redistributing groundwater from mid-latitudes has a larger impact on the rotational pole. And during the study period, most of the groundwater was redistributed in western North America and northwestern India, both of which are mid-latitude locations. Attempts to slow groundwater depletion rates, especially in these sensitive regions, could theoretically alter the change in drift, but only if such conservation approaches are sustained for decades. Now, it's worth noting that the rotational pole of the planet normally changes by several metres every year, so changes due to groundwater pumping don't run the risk of shifting seasons. But on geological timescales, polar drift can have an impact on climate. The next step for this research will be looking into the past. Observing changes in Earth's rotational pole is useful for understanding continent-scale water storage variations. Polar motion data is available from as early as the late 19th century. So, scientists can potentially use this data to understand continental water storage variations for at least the last 100 years. Were there any major hydrological regime changes resulting from a warmer climate, polar motion could well hold the answer. This is SpaceTime. Still to come, a new study says the red planet Mars underwent major climatic changes as its rotational axis shifted about 400,000 years ago, and a new water recovery milestone's been achieved aboard the International Space Station. All that and more still to come on SpaceTime. A new study claims the red planet Mars underwent a sudden change in prevailing weather patterns as the Martian rotational axis shifted about 400,000 years ago. A detailed analysis of data obtained by China's Zhurong rover of dunes located in the southern Utopia Planitia region of Mars suggests the entire planet underwent a major shifting climate that accompanied changes in prevailing winds. A report in the journal Nature claims this shift coincided with the end of the last glacial period on Mars. The authors assessed the surface structure and chemical composition of Martian dunes to determine the age of sand structures and prevailing wind directions at different locations near the Zhurong rover's landing site. They found the prevailing wind direction of the southern Utopian Planitia shifted by nearly 70 degrees from northeast to northwest, eroding crescent-shaped dunes formed during the last glacial period into dark longitudinal ridges after the last Martian ice age. The study's lead author Lai Chun-lai from the Chinese Academy of Sciences says the climate evolution of Mars has been a principal focus for researchers on the red planet for years. He says Mars is the most similar planet to the Earth in our solar system, and understanding Martian climatic processes promises to uncover details of the evolution and history of Earth and other planets in our solar system. Previous research suggested that the Martian climate had changed slowly over time, drifting from a warm, wet world capable of supporting life into the freeze-dried desert we see today. But the inability to directly measure and sample geological formations on Mars has always limited scientists' ability to validate and better characterize the planet's climatic processes. Lai's team used high-resolution orbital cameras and the Zhurong rover's terrain and multispectral cameras, surface composition analyzers, and meteorological measuring instruments to obtain in-situ data directly from the Martian surface. The authors estimated that a change in the angle of the rotational axis of Mars could have caused the planet to exit its most recent ice age. The effects of these changes were subsequently captured by the morphology, orientation, physical properties, and stratigraphy or layering of the dunes on the southern Utopian Planitia where the Zhurong rover landed. The study was designed to integrate rover-scale data from dune formations and weather conditions to not only confirm a change in prevailing wind direction with the close of the last Martian ice age, but also improve general circulation models used to predict finer-scale changes in seasonal wind direction. Importantly, prevailing wind data and dune stratigraphy at the rover's landing site were consistent with the presence of ice and dust layers found at middle and higher latitudes on the planet. Lai says that a great deal of effort is being invested in characterizing the ancient climate of Mars over the course of the Amazonian epoch. That began about 3.55 to 1.8 billion years ago and continues to this day. He says understanding the Amazonian climate of Mars is essential to explaining the current Martian landscape, volatile matter reservoirs, and atmospheric state, and to relate these current observations and active processes to models of the ancient climate of Mars. Observations of the current climate of Mars can help refine physical models of the Martian climate and landscape evolution and even form new paradigms. This is SpaceTime. Still to come, a water recovery milestone aboard the International Space Station. And later in the science report, researchers all agree planet Earth has entered a new geological time epoch, the Anthropocene. All that and more still to come on SpaceTime. For manned missions that venture beyond low Earth orbit, among the many challenges crew face will be how to provide basic needs without resupply missions from the ground. As part of this problem, NASA are developing life support systems that can regenerate or recycle consumables such as food, air and water, and they're testing them aboard the International Space Station. Now, ideally, life support systems would need to recover close to 98% of the water which crews bring along with them at the start of a journey. And the space station's Environmental Control and Life Support System, ECLIS, has now demonstrated that it can achieve this significant goal. ECLIS is a combination of hardware that includes a water recovery system which collects wastewater and sends it to a water processing assembly which then converts it into drinkable water. One specialised component uses advanced dehumidifiers that captures moisture released into the cabin air from people's breath and sweat. Another subsystem recovers water from urine using vacuum distillation, achieving around 94% recovery. Now a brine processor assembly has been added to the urine distillation unit, increasing reclaimable water levels to the targeted 98% needed for long-duration space missions to the Moon and Mars. The brine processor assembly takes the brine produced in the urine distillation unit and runs it through a special membrane technology that blows warm, dry air over the brine to evaporate the water. That process creates humid air, which, just like the crew breath and perspiration, is collected by the station's water collection systems. All the collected water is treated by the water processor assembly, which uses a series of specialized filters and a catalytic reactor that breaks down any trace contaminants that remain. Sensors then check water purity, and unacceptable water is reprocessed. The system also adds iodine to the acceptable water in order to prevent microbial growth. It then stores it, ready for the crew to reuse. Turns out each crew member needs about 4 litres of water per day for consumption, food preparation and hygiene, such as brushing teeth. While the idea of drinking recycled sweat and urine might make most people squeamish, NASA says the end result from the onboard Eclipse processor is actually cleaner than what municipal water systems produce on the ground. This report from NASA TV.
Humans need water to survive. Each astronaut requires about a gallon of water per day. But sending supplies of water to space is difficult and expensive. Resupply will become impossible as humans travel deeper into space. The ability to recycle water on long-term exploration missions is critical to NASA's ability to complete those missions. Thanks to the brine processor, part of the International Space Station's water recovery system, NASA has the ability to recycle 98% of the water collected from the U.S. segment on the orbital outpost, meeting the threshold necessary for water recovery on long-duration space exploration missions. Like something out of science fiction, water from astronauts' breath and sweat is collected by special air conditioners that dehumidify the space station's cabin air. The system also collects the crew's urine and runs it through a urine processor, which produces brine. In 2021, a special brine processor assembly was added to the system, extracting more water and helping to demonstrate that goal of reclaiming 98% of the space station U.S. segment's water. By working toward closing the water loop, NASA engineers are saving millions of dollars and taking us one step closer to long-duration expeditions to the Moon, Mars, and deep space.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Well, there's no more debate about it. Planet Earth has entered and is well entrenched in a new geological time era, the Anthropocene. The 4th International Conference on Stratigraphy has confirmed what scientists have been seeing around them, that Earth has changed radically due to human intervention. And so the International Anthropocene Working Group is now trying to determine the best way of defining the Anthropocene age on the basis of scientific findings and officially declaring it as soon as possible. The researchers are gathering evidence on how specific markers, exclusive characteristics of the Anthropocene, can be used to determine in rock strata exactly when human influence on the Earth's geology became irreversible. This will show future scientists the point where human traces began appearing in the rock strata. Now, various starting dates for the start of the Anthropocene have been proposed. These include the beginning of the agricultural revolution between 12 and 15,000 years ago, although when you think about it, that was actually confined to just one location. The more favoured date, one that's detectable in the planet's geology globally, is the detection of radionucleotide fallout associated with nuclear bomb testing, which began at Trinity in 1945 and peaked during the 1950s. Well, it appears the great weight loss debate might conclude in a stalemate, as US researchers suggest both intermittent fasting and calorie counting end up producing similar results. Scientists split 90 adults with obesity into 3 groups: 8-hour time-restricted eating, a reduced calorie diet, and no change whatsoever. A report in the journal Annals of Internal Medicine found the first two groups lost around the same amount of weight over the study period. However, the fasting group had improved insulin sensitivity compared to the calorie-restricted group. Paleontologists in Chile have identified a new species of hadrosaur, an herbivorous duck-billed dinosaur often referred to as the cow of the dinosaur era. The discovery, reported in the journal Science Advances, challenges long-held beliefs about the range of hadrosaurs in the southern hemisphere. Gonkoken nanoi measured some 4 metres in length and weighed over a tonne. Living during the Cretaceous period 72 million years ago in the extreme south of what is now Patagonia, they could easily adopt either a bipedal or quadrupedal posture in order to reach vegetation. The name Gonkoken comes from the language of the first inhabitants of the region, and it means being similar to a wild duck or swan. There's more big news on the artificial intelligence front today, with the release of the latest iteration of Google's Bard AI and Elon Musk confirming development of his own version of artificial intelligence to be known as X.AI. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Both Google and Elon Musk have been very busy with AI this week. Google has just announced Bard AI's biggest expansion to date. So you can now listen to responses in over 40 languages. If you want to hear the pronunciation of a word or listen to a poem or a script, it's very handy for that. You can enter a prompt and just tap on the sound icon to hear the answers. You can easily adjust the responses. This is something that Microsoft did with Bing AI. You could have casual, you could have conversational, you could have detailed, but Bard has 5 different options. You can have simple, long, short, professional, or casual. And they're starting with English only. You can pin and rename conversations. You can use images in your prompts. You can share Bard's responses. And you can even export Python code to Replit. So, yeah, they've really expanded Bard. Clearly, they want to fight back against ChatGPT. They want to fight back against Bing AI. And they want to fight back against what Elon Musk is playing with AI.
Musk is one of those people who are warning the government about the dangers being posed by AI for both social cohesion and also simply because could AI one day take over the world? Are we looking at a Skynet scenario here? And because there were so many companies involved in researching AI for their own benefit, Musk wanted to counter that with a different AI, one that explores the universe for humanity's benefit. And this sort of follows on from that thesis.
Yeah, it's X.AI. It's obviously his rival to ChatGPT. He says the goal of XAI is to understand the true nature of the universe. And he has said in the past that he wants his AI to understand that humans are a really important part of the universe. We shouldn't be destroyed or gotten rid of like the Terminator and Skynet wanted to do. And he's got a whole stack of former people from ChatGPT, from Google Research, Microsoft Research, Tesla, and the University of Toronto. So he's pulled together as many people as he can to really turbocharge his AI efforts. Now, even though the modern AI that we have today is really a very advanced auto-complete machine. It doesn't actually have any sentience. It might seem like it does. It might seem like you're speaking with a human being, but definitely we're very far from actually having a truly sentient robot that can...
The so-called singularity.
Yeah, we're very far away from that. And I'll have more information about the formation of X.AI and the link to the Twitter Spaces chat on my site, techadvice.life. You can go there to check it all out.
That's Alex Zaharov-Reutt from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.